All right, this is the third FRQ from the 2017 BC exam. So the first question says to find the value of f of -6 and f of 5. They tell us that the graph is of the derivative of f of x, and so that means that if I want to find f of -6, then I'll need to find some of the area underneath the curve. Here they tell us that f of -2 is 7. So what I did first is I said f of -6 plus the integral from -6 to -2 of f prime is what would give us f of -2. And so then to get f of -6, you just need f of -2 minus the integral from -6 to -2. All right, so f of -2 is 7. So we have 7 minus whatever the area is from -6 to -2. The area from -6 to -2 is 1/2 times a base of 4 multiplied by a height of 2. So 1/2 times 4 times 2 is 4. Okay, so we're going to say 7 minus 4. So f of -6. Sorry, that's my phone going off in the other room. F of -6 is 3. So there's our first one. Okay. In a similar fashion, I'm going to say f of 5 plus the integral from -2 to 5. Just kidding. F of 5 equals. F of 5 equals f of -2 plus the integral from -2 to 5, f prime of x dx. And so I have f of 5 is 7 plus, and then I have to find the area from -2 to 5. So the area from -2 to 2 is 1/2 times pi r squared, so pi 2 squared. So that's 1/2 of 4 pi, which is 2 pi, and then because it's underneath the x-axis, that area is negative. And then over here, we've got 1/2 times a base of 3 times a height of 2, which means that has an area of 3. So I've got 7 plus -2 pi plus 3. And so that means that f of 5 is 10 minus 2 pi. All right, part B, on what intervals is f increasing? Well, that's just going to be where the derivative is positive. And here there is a stricter definition of increasing that includes brackets. And to be honest, that is not a strength of mine. I need to look more into those rules, but I have talked to a friend who does grade AP exams, and she says that parentheses are totally fine. They'll go with those on FRQs, and they'll give you full points. So for this, all I did is I looked at the picture to see where the derivative of f was above the x-axis. So that's from -6 to -2, and that's from 2 over 2, 3, 4, 5. So we're going to say it's increasing from -6 to -2, and then from 2 to 5, and that's because f prime is greater than 0. F prime is positive there. All right, next they want to know where there is a absolute minimum. And so to find an absolute minimum, we have to consider where there could be a relative minimum, but we also have to consider the endpoints. So this is the extreme value theorem. So for me to look for a relative minimum, that means I'm going to consider where the derivative switches from negative to positive, because that means that it switches from decreasing to increasing, which is right here. So I'm going to look at the left end at -6, the right end at +5, and then I'm also going to look at +2 because that is where the graph switches from decreasing to increasing. So to do the extreme value theorem, I'll go ahead and write my thinking for that first. So I've got x, I've got f of x, I'm going to plug in -6, I'm going to plug in 2, I'm going to plug in 5. I already know that -6 gives me 3. I already know that 5 gives me 10 minus 2 pi. I haven't figured out what f of 2 is yet. So what I'm going to go ahead and do first is say just f of 2 should be f of -2 plus the integral from -2 to 2. And f of -2 was 7. And then the area from -2 to 2 was -2 pi. And so that means that if I plug in 2, I get 7 minus 2 pi. So this is 7 minus about 6, which is approximately 1, a little bit less than 1. 10 minus 6 is a little bit less than, it's going to be a little bit less than 4. And so if I'm looking for my absolute minimum value, this is where it's going to be. So I'm going to say the absolute minimum value is 7 minus 2 pi, and if you wanted to say where it was located, you could say located at x equals 2. However, they didn't ask where it was located, they just wanted the minimum value. The justification of the answer is this work right here. All right. Part D says to find f double prime of -5 and f double prime of -3. Not -3, sorry, +3. Okay, so f double prime of -5 is just if I look at the graph and I look where -5 is, which is right here, I just need to find the slope of the derivative. So f prime, if I can find the slope of f prime at -5, that's the second derivative. And so right here it goes down 2 over 4 or down 1 over 2. And so that means the slope there is -1/2. And then if I want to look for the slope at 3, that's right here, and I can see that since there's a sharp corner, that's not going to exist. And so I'm going to say this does not exist because f prime of x has a sharp corner at x equals 3. So that means that the limit as x approaches 3 from the left of the derivative of x is not equal to the limit as x approaches 3 to the right. Well, I guess that would be the derivative of this. So the derivative on the left side is positive slope. The derivative on the right side is negative slope. Definitely not going to equal each other there.